Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering soon, and to your relatives. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is problems 97 and 98 on principles of moments or the Varignon's theorem. So in this problem, determine the resultant force R and the horizontal distance x from A to its line of action for cases A and B. So we have two forces here. Both have lines of action downward, so the resultant is also downward. And let us locate the resultant somewhere in between the two forces as shown, R. Then for the first equation, R is equal to 16 plus 12 downward, and the distance of R from the A is denoted by X as shown. So again, R is equal to 16 plus 12. So therefore, the magnitude of R is 28 kilonewtons and it is downward. Since it is a resultant and it is a force, then we should couple it with this direction. Then by principle of moments or Varignon's theorem, the moment of the resultant about point A is equal to the sum of the moments of its components. The components are these forces 16 and 12. Since our reference is at A, the moment arm of 16 is 0 and 12 has moment arm of 7, and the sense of moment of the 12 kilonewton force about A is the same as that of R. Therefore, the sign is the same. So that is R, which is 28 times x clockwise is equal to 12 times 7 clockwise plus 16 times 0. So solving for x is equal to 3 meters, and it is correct. R is 3 meters right of A. For the second part, one is downward, the other is upward. Since the upward component of the resultant is greater in magnitude than the downward component, therefore the resultant is upward and it is 18 minus 12. So for part B, R is 18 minus 12, so R is 6 kilonewtons upward, and let us locate that there. And its distance from A is denoted by x. So the moment of R about A is counterclockwise, so it is R, which is 6 times x, and it is equal to 12 times 0 plus 18 times 4. So 6 times x equals 18 times 4 plus 12 minus 12 times 0, or plus 12 times 0, it doesn't matter. Anyway, the moment arm of the 12 kilonewton force is 0. Solving for x is equal to 12 meters, and since it is positive, so it is right of A. So it is somewhere here or here. So for your part, because I want you to participate in this video, so you should have your part to ensure that you also learn from this topic. Although this is simple, but everything begins from small things for you to become a big person or better student and hopefully better engineer in the future. So for your part, this is the problem. Determine the resultant force R and the horizontal distance x from A to its line of action for cases A and B. So these are the two cases. And for part A, the answer is 42 kilonewtons downward and x is 5 meters right. Then for part B, the answer is 12 kilonewtons upward and x is 4 meters left. So that's it for your part. For problem 98, still on principles of moments or the Varignon's theorem, determine the magnitude of the parallel components at A and B of the force shown in cases A and B. So this is the reversed or opposite problem to the preceding problems. So imagine that 20, this force or this single force is the resultant, and we want to find the components of this force acting at A and at B, A and B. So for the first part, we have to indicate or label the forces FA and FB downward as shown. You can also make them upward if you want. So FA plus FB equals 20. All these forces are downward as shown. We have FA and we have FB. Then for the second solution, we enforce the Varignon's theorem, that is the moment of this single force or the resultant about A or B is equal to the sum of the moments of its components. So the moment of the 20 kilonewton force about B is counterclockwise, and it is 20 times 4. The moment of FA about B is also counterclockwise, so we equate it to the moment of FA about B because they have the same sense. And the moment of FB about B, of course, is 0 because the moment arm is 0. So that is 20 times 4 counterclockwise. The moment of the resultant force is equal to FA times 10. So 20 times 4 is equal to FA times 10 plus, of course, FB times 0. So from here, we can solve for FA, and FA is equal to 20 times 4 over 10, so it is 8 kilonewtons downward. And substituting this value into this equation here, so FA is 8 plus FB equals 20, so therefore FB is equal to 20 minus FA, which is 8. So FB is equal to 20 minus 8, so 12 kilonewtons downward. So I will not present it in more detail here. I'll just put the answer directly because I already mentioned it, and it's a matter of algebra. Even without a calculator, we can still answer that. So FB is equal to 12 kilonewtons downward. So for the second part, the resultant is downward, so let's still assume that the forces components at A and B are also downward as shown. So we have FA downward and FB downward. So first equation, FA plus FB downward forces is equal to the resultant, which is also downward. So that is FA plus FB equals 18. And we reinforce the principles of moments, that is the moment of the resultant about B is equal to the moment of its components about B. So FA times 6 plus FB times 0, both are counterclockwise. So that is 18 times 9 for the resultant. 18 times 9 is equal to FA times 6 plus FB times 0. So I'm not showing FB times 0 anymore. Anyway, it's 0. So from here, we can solve for FA, and FA is equal to 27 kilonewtons downward. And if we substitute the value of FA into this equation here, 27 plus FB is equal to 18. So FB is 18 minus 27, and it is negative 9. So since FA is negative 9 kilonewtons, it means that we reverse the direction of FB, and FB is upward. So FB is 9 kilonewtons upward, and it should be upward. The other way of solving for FB is we sum up moment or we compute the moment of FB about A, which is upward. So 9 or FB times 6, which is counterclockwise. FB times 6 is equal to 18 times 3. So 18 times 3, 54 divided by 6. So it's really 9, and it is upward. For your part, this is your part. Determine the magnitude of the parallel components at A and B of the force shown in cases A and B, so that you can also participate and master the principles of moments. So this is part A, and this is part B, and show that these are the answers. For part A, we have FA equals 24 kilonewtons downward, and FB is 12 kilonewtons downward. And for part B, show that the answers are FA equals 30 kilonewtons upward and FB is 50 kilonewtons downward. So that's it, and I hope that you enjoyed watching this video and it is fun learning, and I hope that I can contribute to your development, and hopefully I can contribute to your success to become an engineer in the future.